Good morning all. I am Karthik, Assistant Professor, Mechanical Engineering Department, SNS College of Technology. This is the video number 5 at the Iron Carbon video lecture series. This final video is mainly about the phases that prevails at the iron carbon diagram, which we have seen briefly on the lecture number 1. So the first one is alpha ferrite. This alpha ferrite has a crystal structure of body-centered cubic. First, second one is it's a pure form of iron. Comparatively, it's a pure form of iron, which because it has the lowest percentage of carbon, up to 0.025% of carbon. It's only prevalent alpha ferrite. And this the properties of alpha ferrite can be similar to delta ferrite, but I have already said the only difference is that high temperature delta ferrite or D ferrite occurs at high temperature and alpha ferrite occurs at low temperature. So it has less than 0.01% of carbon, and it will dissolve easily at room temperature. And moreover, this alpha ferrite is soft and ductile, so it can be the steel which can be applied on the properties with the soft and ductility property can use alpha ferrite as a predominant structure of the steel. So the next one is the important thing that you have to say is that alpha ferrite undergoes extensively cold working property. So as we don't want to go at a high temperature ranges. The second thing is that austenite. The austenite is an interstitial solid solution, as I already said, and carbon, which has the atomic radius of 0.56 Armstrong, will be placed in between the iron atom, which has the atomic radius of 1.56 Armstrong. So in this manner, we can say this carbon will be implemented, or carbon will be placed in between the iron atoms. So this so austenite forms interstitial solid solution, and that too austenite has the loop between ACM and A3, and that too at the lowest part at 0.8, and at the right part it is up to 2.06. So this austenite has the highest slope, and the other thing is that it is face-centered cubic and has the maximum solubility of carbon, as I said previously. And moreover, it is more softer than ferrite, much softer than ferrite. So as you can see at the temperature range, it occurs at 723 degrees Celsius and up to 1400 degrees Celsius. It is not available at room temperature. But still we can see this austenite at the room temperature, which because this austenite, it's because we are using stabilizers. We are using austenite stabilizer. This austenite stabilizer will help to keep the austenite stable up to in the room temperature. So it is most easily hard work property, and that too it has a non-magnetic one. Okay, the austenite has the non-magnetic one. The third one is cementite. It's an intermetallic compound. As why it is intermetallic compound is that you can easily see it any phase diagram. If the component is lying at the straight line, you can say it's an intermetallic compound. First one. Second, which it has 3% of 3 atom of iron and 1 atom of carbon. Due to this, it is hard, brittle, and white in color. And that too, it melts at 1800 degrees Celsius. Okay. The third one is that it is purely occurs at the vertical line at 6.67% of carbon. In the presence of steel, it increases hardness, but it reduces ductility and toughness. So the cementite will increase the hardness, but at the same time it will reduce the ductility also. So the fourth phase is perlite. Perlite is nothing but a combination of iron and cementite, or otherwise known as ferrite and cementite. This perlite is also known as eutectoid mixture. It is the most available constituent of steel. It is most available in most of the steel. Most of the steel microstructure has a little amount of ferrite, which because this ferrite and cementite combination will helps to improve the hardness and strength of the steel and ductility of the steel. But moreover, this perlite can be easily, as you want to see perlite microstructure, the fingerprint as you keep with the help of stamp pad, if you place a fingerprint on a paper, this the design that is formed in the paper is similar to the perlite microstructure. So you can see some laminar structures that are available like a wave like this. So this laminar structure helps as a crack movement barrier, and also gives toughness to the particular component. Okay, so that's all for this video lecture on iron carbon phase diagram. Thank you.